the bottom of the western Pacific Ocean, in a crescent-shaped depression in the ocean floor approximately 2,000 kilometers east of the Philippines, there is a point that is further from the surface of the sea than Mount Everest is above it. The Challenger Deep. The deepest point on the surface of the Earth. 11,000 meters below the waves, nearly 7 miles of water pressing down with a force of approximately 11,000 pounds per square inch, a pressure so extreme that it would crush an unprotected human body to a fraction of its normal volume in milliseconds. The temperature is approximately 1 to 4 degrees Celsius above freezing. There is no light. There has never been light from the sun at this depth. In the specific absolute darkness of the Hadal Zone, the ocean's deepest realm, named after Hades, the Greek underworld, life exists in forms so strange and so specifically adapted to conditions of extreme pressure and cold and darkness that their discovery has repeatedly forced the revision of what biologists believed was possible. More human beings have stood on the surface of the Moon, 12, during the Apollo program, than have descended to the deepest point in the ocean. The number of people who have been to the Challenger Deep is fewer than 30. Fewer than 30 human beings, in the entire history of the species, have gone to the deepest place on Earth. The first were 2 men in a steel sphere in January 1960. Their names were Jacques Piccard and Don Walsh. They descended in a vessel called the Trieste, a bathyscaphe, a self-propelled deep-diving vessel whose design combined a pressure-resistant observation sphere with a large float filled with aviation gasoline for buoyancy, and they reached a depth of approximately 10,912 meters in a descent that took 4 hours and 48 minutes and that very nearly ended in catastrophe when one of the outer plexiglass window panes cracked on the way down, sending a shudder through the entire vessel that both men momentarily feared was the beginning of a catastrophic implosion. The window did not fail. They continued down. They reached the bottom. They looked out through the remaining window into the absolute darkness of the Challenger Deep and saw, in the beam of their searchlight, something that the science of the time said could not be there. A flatfish. Lying on the sediment of the deepest point on Earth. Moving its fins. Life at the bottom of the ocean. Life at a pressure of 1,000 atmospheres, in water near freezing, in complete darkness, at a depth that no previous human observation had ever reached. Life where the physics of the environment seemed to make life impossible. They stayed on the bottom for 20 minutes. They turned around and came back up. They brought no samples. They took no photographs. The camera they had brought failed to produce usable images. But they had been there. 2 human beings had descended to the deepest point on Earth and had seen with their own eyes that something was alive in the darkness. The story that led to Piccard and Walsh's 1960 dive begins not in the deep ocean but on the surface, in the specific history of oceanographic exploration that began in the second half of the 19th century when the scientific community first began to take the deep ocean seriously as a subject of systematic investigation rather than a terrifying void best left unexamined. Before the 19th century, the deep ocean was almost entirely unknown. The specific combination of the ocean's opacity, you cannot see into it, and the specific technical difficulty of reaching any significant depth meant that what lay below the ocean's illuminated surface layer was a matter of speculation rather than observation. The speculation was mostly negative. The abyss was presumed to be cold, dark, lightless, and lifeless, a void whose pressure and temperature made the existence of any living thing impossible. The naturalist Edward Forbes contributed significantly to this specific misconception. His systematic dredging of the Aegean Sea in the 1840s had produced the specific observation that the density of organisms decreased with depth, leading him to propose the azoic hypothesis, the suggestion that below approximately 500 meters, life in the ocean simply did not exist. The specific combination of Forbes's scientific authority and the apparent logic of the hypothesis, deep water was cold, dark, under high pressure, and distant from the photosynthetic basis of the food chain, meant that the azoic hypothesis was widely accepted for decades despite the specific problem that the ocean dredges of the period were routinely bringing up organisms from depths supposedly too great for life. The voyage that changed everything was the HMS Challenger expedition of 1872 to 1876, the first systematic scientific investigation of the deep ocean, conducted by a converted Royal Navy corvette equipped with dredges and sounding equipment and the specific scientific personnel needed to analyze what the equipment brought up. The Challenger expedition spent 3.5 years at sea, covering approximately 68,000 nautical miles and conducting sounding and dredging operations at approximately 492 stations across every major ocean basin. It was during the Challenger expedition that the deep trench system of the Western Pacific was first identified. The Challenger was taking sounding measurements in the Mariana region of the Western Pacific in March 1875 when she recorded a depth of approximately 8,184 meters, far greater than any previous depth measurement and the specific first indication that the ocean contained trenches of extreme depth. The specific location was recorded in the expedition logs and eventually gave the deep trench the name it still bears, the Challenger Deep, in honor of the ship that first identified it. The Challenger expedition destroyed the azoic hypothesis conclusively. The dredges brought up organisms from every depth they reached, including the greatest depths sampled. Life existed throughout the water column, adapting to whatever the specific local conditions required, including the deep ocean conditions of cold and darkness and pressure that Forbes had declared incompatible with living organisms. The specific lesson that the Challenger expedition taught, that life is more adaptable and more pervasive than any theory predicts, has been repeated in every subsequent extension of biological exploration into extreme environments. The systematic measurement of the ocean's depth, and the specific determination of the precise location and depth of the Challenger Deep, required decades of improving technology after the Challenger expedition. The early sounding methods were laborious and imprecise. Lowering a weighted line to the bottom and measuring the length paid out was time-consuming and subject to specific measurement errors from currents carrying the line at angles and from uncertainty about when the weight had actually reached the bottom. The development of echo sounding, the use of acoustic pulses whose travel time to the bottom and back provided a direct and precise depth measurement, transformed deep-sea bathymetry in the early 20th century. The USS Challenger survey in 1951, using echo sounding, identified a specific location in the Mariana Trench with a depth of approximately 10,863 meters and named it the Challenger Deep in honor of the original expedition. Subsequent surveys with increasingly precise acoustic equipment have refined the measurement repeatedly, with the current best estimate placing the deepest point at approximately 10,928 meters, nearly 11 kilometers below the surface. The triste that Pickard and Walsh used for their 1960 dive was the most extraordinary engineering achievement in the history of deep-sea exploration up to that point. The vessel was designed by Auguste Pickard, Jacques' father, the Swiss physicist who had pioneered stratospheric balloon flight in the 1930s and who applied the same principles of buoyancy engineering to deep-sea exploration. The specific design, a pressure-resistant steel sphere suspended beneath a large float filled with aviation gasoline, used the same physics as a balloon but inverted, the gasoline providing positive buoyancy that held the sphere up until iron pellets were released to increase the overall density and allow descent. The sphere itself was a masterpiece of pressure vessel engineering, constructed from steel approximately 12 centimeters thick, designed to withstand the crushing pressure of the deep ocean while providing a habitable space for the two occupants. The specific inner diameter was approximately 2 meters, barely enough for 2 adults to stand in, with minimal space for instruments and life support equipment. The 2 plexiglass windows were conical, thicker on the outside than the inside, so that the ocean pressure actually sealed them more tightly rather than pushing them inward, and their design was the product of the specific engineering insight that high pressure can be used as a structural asset rather than merely a challenge. The preparation for the January 23, 1960 dive was conducted with the specific methodical thoroughness of a test program pushing beyond the limits of all previous experience. Jacques Pickard, who had been working with the Trieste for years and who had conducted multiple previous dives in the vessel, and Don Walsh, a United States Navy officer whose specific naval training and whose specific role in the project reflected the American military's interest in deep-sea exploration, prepared the vessel and themselves with the knowledge that they were going somewhere that no human had ever been and that any failure of the pressure vessel or any of its systems at depth would be instantly and irreversibly fatal. The descent began at 8:23 in the morning on January 23, 1960. The Trieste sank at a rate of approximately 1 meter per second. At 11 minutes past 12 in the afternoon, 4 hours and 48 minutes after beginning the descent, the vessel touched the sediment of the Challenger Deep at a depth of approximately 10,912 meters. The crack in the plexiglass observation window, The specific moment of near catastrophe that Pickard recorded in his account of the dive occurred at approximately 9,000 meters on the way down, producing the shuddering impact that both men felt as a physical blow to the entire vessel. An inspection revealed that only the outer plexiglass window had cracked. The inner window, the actual pressure boundary, was intact. They continued. The view from the bottom was the specific view of a dark and apparently featureless sediment. The bottom of the Challenger Deep is covered in a thick layer of diatomaceous ooze, the accumulated remains of billions of microscopic organisms that have been sinking to the bottom for millions of years, illuminated by the Trieste searchlights in vivid contrast to the absolute darkness beyond their range. And then the flatfish. The specific observation that remains the most debated detail of the dive, whether what Pickard saw was actually a fish, whether a true fish could survive at this depth, whether it might have been a sea cucumber or a polychaete worm misidentified in the excitement and the unfamiliarity of the environment, has been analyzed by marine biologists for 6 decades without definitive resolution. What is not debated is that Pickard and Walsh were there. That they had descended to the deepest point on Earth. That they had survived. And that they had spent 20 minutes on the bottom before releasing the iron ballast pellets and beginning the 3-hour 17-minute ascent that brought them back to the surface. The Navy's interest in the dive was practical rather than purely scientific. The Cold War context of 1960 meant that the American military's support for deep-sea exploration was partly motivated by the specific strategic question of whether nuclear submarines could operate at extreme depths and survive. And the Trieste's successful descent to the deepest point on Earth provided specific data about pressure vessel performance at extreme depth that the submarine program valued. The subsequent history of Challenger deep exploration was, by the standards of the achievement, surprisingly quiet. The Trieste's dive was a feat of extraordinary courage and engineering, but the specific vessel and the specific technology of the bathyscaphe were not well suited to the systematic scientific exploration of the deep ocean. The passive nature of the vessel, which sank and rose rather than maneuvering freely, and the limited observation capability of the single window and the single camera meant that scientific investigation was constrained by the platform's limitations. The first return to the Challenger Deep with maneuvering capability came in 1995, when the Japanese remotely operated vehicle Kaiko descended to the deep and conducted the first systematic sample collection and bottom photography, bringing back sediment cores and microbial samples that revealed the specific biology of the Hadal environment in unprecedented detail. The specific discovery that Kaiko and subsequent Hadal exploration vehicles have made about the life of the Challenger Deep is one of the most remarkable in the history of biology. The Hadal zone, the deepest trenches of the ocean, is not the lifeless void that Forbes had predicted and that the specific hostility of the environment might suggest. It is a specific and highly productive ecosystem whose food supply comes from the organic material, the marine snow of dead organisms and fecal matter and particulate organic carbon, that falls continuously from the productive surface layers above and is concentrated in the trench geometry by the same mechanisms that concentrate sediment. The organisms that have been found at the greatest depths of the Challenger Deep include amphipod crustaceans, shrimp-like creatures that have been recovered in enormous numbers from Hadal traps, their specific adaptations to pressure including the specific chemistry of their cell membranes which use different fatty acids at extreme pressure than shallow water relatives use at normal pressure. The bacteria and archaea of the Hadal sediment, the microbial community that forms the base of the Hadal food web, have been found to be extraordinarily active metabolically, processing the organic carbon that sinks from above with an efficiency that challenges previous understanding of deep-sea biogeochemical cycling. The famous second crewed descent to the Challenger Deep came in 2012, when filmmaker and explorer James Cameron descended in the deep-sea Challenger, a narrow vertical submersible of his own design that he had spent years developing with a team of Australian engineers. Cameron reached the bottom alone, the first solo descent to the Challenger Deep, and spent approximately 3 hours on the bottom conducting scientific observations and sample collection before ascending. The specific achievement of reaching the deepest point on Earth in a vessel designed to enable scientific work rather than merely to survive the journey was the specific advance over the 1960 dive that 52 years of engineering progress had made possible. What Cameron found on the bottom, in the specific additional 3 hours that his more capable vessel allowed compared to Pickard and Walsh's 20 minutes, was a landscape of surprising geological interest. The flat sediment of the main basin gave way, in the sections he surveyed, to sloped surfaces and ridges and the specific geological features of a trench system that is geologically young and tectonically active. The white shrimp-like amphipods he observed were present in enormous numbers. The sediment was soft and fine, the accumulated deposition of millions of years of marine snow. He brought back samples that the scientific team analyzed for years afterward. The microbial life in the sediment cores. The specific chemistry of the bottom water. The particular foraminifera, microscopic shell-building organisms, preserved in the sediment whose species composition told the specific story of the Mariana Trench geological and oceanographic history. The period from 2020 onward has seen an extraordinary expansion of Challenger deep exploration with the development of full ocean depth capable manned submersibles by the company Triton, whose DSV limiting factor, operated as part of the 5 Deeps expedition led by investor Victor Vescovo, descended to the Challenger Deep in 2019 and reached a new measured depth of 10,928 meters, the deepest point yet confirmed. Vescovo subsequently made multiple additional dives, conducting the most systematic scientific program yet attempted at the bottom of the ocean. What was found during the 5 Deeps exploration of the Challenger Deep was both scientifically significant and specifically sobering. Among the samples recovered from the deepest point on Earth were microplastics. Plastic particles, the specific product of human industrial civilization's decades of plastic waste entering the ocean and being carried by currents and sinking through the water column, had reached the bottom of the ocean. The Challenger Deep, the most remote and most inaccessible place on the surface of the Earth, had been contaminated by human activity. The specific implication, that the deepest trench on Earth is not isolated from the surface world but is connected to it by the continuous rain of material that sinks from above, is both ecologically significant and symbolically overwhelming. The planet's deepest point is not pristine. The microplastics in the Challenger Deep sediment are the specific fingerprint of a civilization whose waste products have reached everywhere. The surface is 11 kilometers above. The pressure is 1,000 atmospheres. The temperature is barely above freezing. The darkness is absolute. And there are microplastics. The Challenger Deep has been reached by fewer than 30 human beings. It has been contaminated by 8 billion. The deep ocean is the last unexplored frontier on Earth. More of the ocean floor has been mapped in less detail than the surface of Mars. The specific combination of the technical difficulty and expense of deep-sea exploration and the specific lack of the commercial motivation that drives other kinds of exploration has meant that the Hadal Zone remains, despite the remarkable discoveries of the past 6 decades, one of the least understood environments on Earth. Jacques Piccard died in 2008. Don Walsh lived to see the 5 Deeps expedition and beyond, advising and encouraging the next generation of deep-sea explorers with the specific authority of the man who first went to the bottom of everything and came back to tell the world what he had found. He found a flatfish. Or something that looked like one. In the darkest place on Earth. It was enough to change what the world knew about the limits of life. It always is.